Okay, welcome to grade 11 college math. We're entering a new unit, Unit 6, in Chapter 3 in our book. And our first lesson is, first lesson is 6.3.1, and also referred to in our note as sampling techniques. So our unit is on one variable data for statistics. So our goal is to describe how data can be collected for a survey. All right, so we have different types of survey data. Now this particular part doesn't match exactly with your note, but it's important information, so you might want to copy this out. So we have certain data that is called categorical data, and it is qualitative, meaning we can describe things with it, like colors, sports, cars, data that are types rather than numbers. So they're not measurable, they're just sort of ways to categorize things. Sample survey questions are, what brand of cell phone do you have? They can only be quantified by counting similar survey responses, like 20% of the people own an iPhone, for example. Okay, the next one is called discrete data. So discrete data is quantitative, so we can put numbers to it. The data can be counted but has a specific or finite value. So there's no in-betweens, there's whole numbers. So for example, the number of correct questions on a quiz, or the number of green M&Ms in a bag. You can't have half of a green M&M or a quarter of a green M&M. These are full numbers, so usually discrete is complete numbers. Sample survey questions would be, how old were you when you got your first cell phone? You can analyze using statistical measures, like average age for a cell phone is 15 for your first cell phone, for example. Okay, the next one is opposite to discrete, it's continuous. And continuous data has those in-between numbers. So data that can have any value within a given range or interval. For example, heights of students in a class or studying time for a test. So for heights of students, you could have, decimal values in centimeters. Time studying, you could have, 2.5 hours or 1 hour, 45 minutes. You can have in between times. Sample survey questions, how many text messages do you send in a day? Or can you can analyze using statistical measures, like 25% of grade 9s send at least 10 texts a day. Well, let's try these ones out now. We're going to just describe these as D for discrete, discrete. Categorical, and continuous. So what would be the number of suitcases lost by an airline? Okay, well, you can't have half suitcases lost, so this would be a discrete. Okay, the favorite snack food of moviegoers. This one's difficult because there's no numbers to it, so this is a categorical. The length of time it takes for a light bulb to burn out, number 3. Well, these numbers could vary. They could be half minutes, half hours, so it's continuous. the height of corn plants. Again, we could average those out. We could have in between numbers, so those are continuous. There's such a wide range. Now, college and university students attend after high school. The college or university students attend after high school. Well, again, there's no number to measure the college, so in fact, these are more like categories. So, um, Algonquin College, La Cité, Collegiale, or maybe you're heading up to down to Seaway College, or you're going to Centennial College, or maybe you're going to University of Ottawa or Carleton University. Those are all categories. Number 6, a starting salary for people fresh out of college or university. Again, there's quite a range. There's decimal values in there. There's a whole range of numbers. So those would be continuous data. Now, the time it takes for a battery to die. Again, too much of a range here. Too many in-between values. That's continuous. The production of tomatoes by weight. Well, that would probably be very defined. So I have it down as discrete. You could make an argument for it to be continuous, but the monthly spending habits of students. Again, lots of range here. Monthly spending habits. Now, it depends. Are you talking about what they tend to spend money on, or how much they are spending? If it was what they're spending it on, it could be categorical. If it's how much they're spending, that could be continuous, because it could be such a range for different people. What about the month in which students have their birthday? Again, these tend to be categories because they're months, not really values. And you could make an argument that it's discrete, but so we'll say both, depending on the context of the survey. The number of students in each Ontario high school mathematics classroom. Well, we could actually find those numbers out if we really, really wanted to, right? The government could figure that out, or question school boards and schools. So we could get a really discrete, exact number there. Okay, so that's sort of keeping that in mind, categorical, discrete, and continuous. Keep those terms in the back of your mind. Let's just go through. There's a lot of theory in this note, so please don't mind my handwriting. It's not the neatest, but we'll fill in these blanks as we go along. So a survey is a method of collecting information about a population. A census, we talked about a census in the last note, in one of the last lessons. The census collects information about everyone in a certain population. Okay. A population is all the individuals or items that belong to a group being studied. Right. So this could be things, people, or things, right, that we're talking about. For example, all students in the grade 11C math class. Okay, a sample. A sample is a group of individuals or items that represent a population. That is a sample. So a sample of people. Okay. from which they are taken. For example, grade 11 college math students from this class. There's a much more specific sample. So this is a sample from a bigger population. So the population would be all grade 11 math students, and then this would be grade 11 math students just from this class would be a sample. Another term that we just briefly mentioned last lesson was a bias. Now, bias occurs when the results of a survey do not reflect the population. So you can imagine maybe the sample group has a certain opinion that makes them choose their answers a certain way that don't really reflect the entire population. So, just surveying a grade 9 phys ed class of boys and they all respond a certain way doesn't really reflect what the whole population of the school would say. So then we say there's a bias there. Okay, here are sampling techniques. So how do we gather our answers? So in a class, you could say we have a simple random sample. Each member of the population has an equal chance of being selected. It's random. So you put numbers in a hat and select students numbered 3, 7, 9, 10, 12, 24. It's very random. Okay, what's the problem with doing randomized samples? Well, not always an accurate representation. You just might sort of get the wrong group that doesn't really represent the big population. So not always the accurate representation of the population as a whole. Okay, number 2, this should say number 2 here. Systemic sampling. Well, every nth meaning any number, any nth member, every certain number of the population is selected. So sample every 4th person or sample every 7th person. Okay, so that's one way of doing it. Population is better represented with 3 boys and 3 girls, for example. That would be another idea. Okay, so that nth number could change to anything, right? So here we go. Our third example, again, changing these numbers, a stratified random sample. The population is divided into subgroups. So, for example, by age or gender or nationality, those are just ideas. And a random sample is selected from each subgroup in proportion to its size in the population. So let's just recap that. The population is divided into 2 subgroups, and a random sample is selected from each of the subgroup in proportion to its size of population. So if you had 16 students, a quarter of them were boys. If you would need 4 boys. If you had 8 students, a quarter were girls. You would need 2 girls in your sample. so that the same proportion, 1 out of 4, 1/4 of the proportion remains the same. Okay. Again, these numbers we're just numbering these. Okay, our fourth example is voluntary response sample. A voluntary response sample. This sample of people contains members of the population who have chosen to respond to the survey. In other words, they can fill out a comment card, they can respond to, when you go to a store and you have a little survey at the bottom of your receipt. Some people fill those out because there's a chance to win something, or they really do care about commenting on the business. Now, could we see a problem with that? Again, you're getting a response only from people who have a particular interest in this. So often people respond to surveys when they're upset or they're not happy. So that could be skewing, the overall responses, right? That only people that feel like they haven't been treated well are going to respond and complain. So you might get more negative feedback than you would anticipate. Okay, or likewise, it could be people that are just so ecstatic about it that they are choosing to respond. Or it could be your family members, and you ask all your family members to do the survey to make your business sound extra better. But anyways, those are just, so there's pros and cons to each of these, and sometimes the bias. Remember we talked about bias being a big part of it. Now here's the next one, cluster sample. The population is divided into clusters, and a certain number of clusters are chosen. Every member of the cluster is part of the sample. So again, you might group these surveys into clusters of, 100 people in all these clusters, and then in the end you only use 2 of those clusters or half of the clusters, and so then it's kind of randomized that way. Again, pros and cons. There's some randomized. That's a good thing because you're kind of getting rid of that bias. But then again, because it's clustered, you never know. You might get more of the same type of person in one cluster. Anyways, so let's continue. So convenience sampling. The sample contains those members of the population from which data is most easily collected. Sample contains those members of the population from which data is most easily collected. You might, want information on taxes, about how people do their taxes. And if you are putting this out to the community, then, people that are financially have good knowledge of finances, or people that are tax professionals, well, they might do that more often or more easily than someone else. So then it's kind of a convenience factor. What else? Maybe people are doing surveys because they are convenient, meaning I can quickly use an app on my phone, do it, and I don't have to fill out any paperwork, so it's convenient. It's right in my fingertips. But if it's something I have to request, then it's sent to me, then I have to wait for it, then I have to fill it out and then mail it. That's probably, a bit more work that I want to do, so I might not fill it out. So then you're only getting people that are can do things out of convenience. Okay, so here's some examples, and we'll just sort of work through this here. Okay, so a high school vice principal enters the cafeteria and randomly selects 2 tables. All students at those two tables are surveyed. So what is the population? So if we go back to our um, definitions, right? What's a population? All the individuals or items that belong to a group being studied. So what's the group being studied? So we'll say it is the high school students. What is the sample? Well, people, you can kind of get it here. Right? People at selected tables. Only at the selected tables. What is the type of sampling? Well, you have people sitting at tables in clusters. So it's a cluster sample. Right? You kind of ignore those other tables and you just picked random tables of clusters. So is there a bias in this survey? Explain. Well, I don't know about you, but when I'm at a cafeteria table as a teenager, I'm probably sitting with my friends. My friends have the same types of interests, the types of same views that I have, the same beliefs, and so we might all sort of fill out a survey similarly. So that would be the main concern. So yes, there is a bias. People sitting at tables may be friends with the same views, right? Or opinions, interests, right? So therefore, probably have the same responses, but it is a random sample. So kind of pros and cons here. Pros and cons. It is random, so that's a good thing, but there is this chance of bias. Well, let's read the next one, and you should try this out yourself. Maybe. So, read this over. Call this question 2. Call this question 3. And then see if how much of these blanks you can fill in yourself. So pause the video, try it out, and then restart the video when you're ready. So anyways, okay, so a school is divided into 4 groups by grade. There are 300 grade 9s, 350 grade 10s, 270 grade 11s, and 320 grade 12s. Proportion of each group, a proportion of each group chosen, 10%. Okay, 30 grade 9s were surveyed. If you notice, if we take 10% of each of these, we get 300 is 30, 350 is 35, 270 is 27, and 10% of 320 is 32. So what is the population? So again, I think we're just talking about high school students here. Okay, now, what is the sample though? The sample is 10% of students, all right, from grades 9, 10, 11, and 12. So what is the type of sampling? Well, we're taking a measured amount of every group. So when we talked about that, we called that a stratified sample. Okay, good. Is there a bias? Well, you can kind of make an argument in all cases that there is a bias, but in this case, we're pretty spread evenly across the board here. No, it is. So we're going to say no, it is a fair representation of the population. Now, that's the argument for no. You could argue that yes, there is. The survey, so we can make a case for both, could be age sensitive. Now, this is just one example. You might come up with other reasons on your own. Let's say if it was about driving, right? Example. Well, grade 9s and 10s aren't going to have a lot of opinion or knowledge about driving. They might think they do, but the grade 11s and 12s will have a more informed decision about that. Or let's say it was, I don't know, about the latest video game craze. Well, maybe by grade 11 and 12, you're kind of moving beyond that, and the 9s and 10s are much more, hyper focused on that type of information. Okay, let's go through another scenario here. Students from Miss Bailey's math class are given a survey assignment. Crystal goes home and surveys her immediate family only. Does that sound like a good idea? Okay, so just a little note here. Surveys become more reliable with increased sample size. So, even surveying 30 people, one class does not represent, a school of 2,000 people. So where does that number become? Well, maybe, is 200 people out of 2,000 better? Is 1,000, a good indicator of what 2,000 would think, right? So you always have to think about when they do polls and they're talking about elections, they're calling thousands of homes across Canada randomly to find out what people intend to vote. And they do so many of those that they safely think that they have a big enough sample size that represents Canada and what Canadians will do. But if you just called 10 people in Stittsville and said who you're voting for, that would not, and then you said, oh, this is a national poll, that would not be realistic at all. Anyways, let's keep going. So who's our population? Well, the population depends the population depends on the survey question. So students in this class were given a survey assignment. It doesn't tell us anything more about that. Crystal goes home and asks her immediate family. So it really depends on what the survey question is. Is it having to do with sports? Is it politics? Is it their opinion about something. What would they choose? So really, we're not given enough information. What is the sample? Well, people in a family, only one family. The type of sampling, well, Crystal sort of took the easy way out here, and she did a convenient sample. All right, good. Is there a bias? For sure. Yes. Likely to have similar views in a family. Okay, so it definitely doesn't resemble the rest of the population or what you're really aiming for in that assignment, let's say. So keep that in mind. If you want your surveys to be more reliable in the future, you want to have large sample sizes. Okay, what are some advantages and disadvantages of these sampling techniques? So we touched on each of these, so now we can kind of summarize it. So maybe think about these as we go along. So what's a simple random? Well, the advantage is it is not biased because you're not singling out a group of people. The disadvantage is you may be more difficult, right? You got to work a little harder to get the people involved. You might have to come up with a selection process. What about a stratified random? Well, all parts of the population are equally sampled. So that was the example, like the 10% of every grade, right? So that was good. That's an advantage. What's the disadvantage of that? Again, it might be maybe more difficult to arrange this, more planning, more difficult. It could also involve, like, it could be expensive, right, to do something like this. So, all right, systemic. All right, systemic. Well, again, things are already in place. They're easy to reach out. You kind of have a way of like saying, oh, every second person or every 10th person that we're going to talk to. So they're usually easy to do. And but however, their disadvantage is they can be biased because you're taking from the bigger, similar group. You're just taking every second or third or fourth or every fifth person in that group. Okay, voluntary response. Well, an advantage is, well, you don't have to do much advertising or outreach to do it, so it may be less costly. Disadvantage? You don't have to pay someone to go and call everyone or make flyers or whatever you do. So that might cut your costs. Now, the other thing is they may be biased because only the people that really have a vested interest in doing it will be motivated to do the survey. So they either want to complain about something, or they're going for a prize, or they really like that topic, and so they're not going to give you, or that they really like that product. So they're already skewed to sort of agree with liking it anyways. So here we go. And then what about clustering? So what about clustering? Clustering is pretty easy to do because you're just saying, like, this group of people and this group of people are already close together or associated. They're easy to gather over. The problem is you're not really randomizing it, so it's biased. And finally, of convenience. Well, again, easy to do, right? You don't have to work hard to find these people. They're already. I could survey you guys pretty quickly. I could make it an assignment and make you do it, and that would be pretty convenient for me if I was going to try and figure something out like that. But and anyways, when we do that, it's often biased as well. All right, thanks for going through all that. And you have a worksheet with the same number of the notes, so 6.3.1 worksheet to do as homework, and you have questions in your textbook that you can practice with as well. Thank you for watching, and we'll see you next time.